preface this tutorial by saying that I just recorded a CG Matter tutorial, so my voice is gone and it might crack every once in a while, so that's going to be embarrassing for me. So, first of all, what are drivers and what am I going to be teaching you? So remember from the last 4 parts, assuming that you've seen those, we have a combined RGB node, which is basically saying, let me just add another that we haven't altered yet. A combined RGB node is just a way to choose a color by picking a red, green, and blue amount, so I can make it more red. As we approach 1, it becomes fully red, and we can mix it with something that's fully green, so red and green make yellow. And then if we also add 1 for the blue, which means maximum amount, we are going to get white, because we have maximum amounts of red, green, and blue, and then conversely, if these are all 0, we get black. So we already know what combined RGB is, but you can see that my version, which I'm going to connect, my version is purple. And you may be thinking, okay, what's up with that? Well, what does that do? Well, what these sliders are actually rigged to do right now is notice what happens when I take my cube and move it. Oh, so moving it is actually altering what these values are. And you can see once I finish a movement, so I'm just going to click here, you can see I moved it along the x-axis, and this has updated for red to 2.665. And if you're thinking, oh, did I take this x value and copy it here dynamically? Then yes, that is exactly what I did, and that is exactly what a driver is. So we have a pretty simple setup. We can either control it by moving these location sliders, which again are the same as these sliders, or we can just move it in the viewport. So if we want something that's perfectly red and green, meaning yellow, we just set this to 1, set this to 1, and you can see these don't really update that quickly. Viewport. So if we want something that's perfectly red and green, meaning yellow, we just set this to 1, set this to 1, and you can see these don't really update that quickly. It's kind of strange, but usually you just have to toggle a frame and it happens. You can see that it's actually updated. And again, this works dynamically, and that is the point of drivers. And the z-axis I reserve for making it blue. But again, it only goes between 0 and 1, so once you go past an x value of 1, it just remains red. Okay, so this is what a driver is. I think you understand the demo, so let me just go full screen and start up a new scene. And then I guess there wasn't really too much point to that because we just need to go to the shading workspace. You know what that's all about. It's where you edit your material. So again, probably the last time I'm going to say it for this tutorial, and I'm not going to say it in future ones, hopefully. We have a cube that is some geometry, which has this material assigned to it with the name material, and that material is basically made up of this node network. With this node network, I'm going to replace this principled BSDF with Shift-A to add, and then I'm just going to type in, you can either do an RGB node technically, but what I would recommend is combine RGB, because then we can actually manipulate these sliders individually. And then additionally, like we talked about, we can add in a value, which is a single number, to control this instead, if we just want to separate it for some reason. So to do this driver stuff, it used to be pretty hard, but now that we're using 2.81 and onwards, it's actually gone a lot easier. What we have to do is I'm going to hit N to reveal this location, rotation, scale stuff, or you can go to the object data, I think. No, it's one of these. Object properties, yeah, here you have location, rotation, scale. What we're going to do is we're going to right click any value that we want. So let's say we want the X location, you right click and then you click copy as new driver. So we are going to be copying this X value, whatever it is, no matter what we update it to, as our driver. And then let's say we want this affecting our red channel. We right click and then do paste, there we go, paste driver. And now when we change this X value, you can see after we toggle the frame, it's actually going to update here. And you can tell that it's being affected by driver because it's. And now when we change this X value, you can see after we toggle the frame, it's actually going to update here, and you can tell that it's being affected by driver. driver because it's purple, frame it's, and now we right click and then do paste, there we go, paste driver. This affecting where it is, no matter what we right click and then do driver. And then let's say we want this affecting our red channel, we right click and then do paste, there we go, paste driver. And now when we change this X value, you can see after we toggle the frame, it's actually going to update here, and you can tell that it's being affected by driver because it's purple. And of course, you can do this dynamically, and you should be able to animate this and have it update per frame. So if on frame 1 we want it to be 0, we can add a keyframe here. Frame 40, we'll have it go to like 3. Again, it doesn't matter once it goes past 1. I mean, I guess it does matter a little bit since we're not on standard. Again, standard actually has an accurate 0 to 1 where anything beyond 1 remains white, whereas Filmic has this 0 to infinity thing. You can watch a video about that I made if you care. And you can see that it's actually dynamically doing it per frame. And of course, we can do the same thing with other stuff. So for example, we can actually take the same driver, and it's still in the copy. We can still paste the same driver over and over. We can right click on green, we're going to paste it, and then we're also going to do it for blue. And I want you to think about what's going to happen before I play this animation. One value, being the X location, is controlling this red, green, and blue. So what do you expect to happen? We play this. It remains perfectly grayscale, so it goes from black to gray to white. And that's because at all points, at every frame, these 3 sliders are going to have the same value, so you have the same amount of mixing. So that should be pretty intuitive. And I just want to really stress the point that you could do this for anything. So let's say we take the Y location, copy as new driver, set this to paste. So now, let me actually remove the animation here so we're no longer messing with that. So now, X-axis controls the amount of red. Whoops. Let me remove this driver. By the way, if you want to delete a driver because blue is still being affected, bunch of ways to do it. The easiest way is to right-click and then delete driver. You can either do that or go into the driver editor, which is one of these somewhere in here. There should be drivers. Yeah, here, drivers. But now we should be able to move to the X-axis to affect red and move along the Y-axis to affect green. And these things, of course, mix because of this combined RGB. We can do the same thing by just putting it in a value thing that goes to green. It's an equivalent setup, although there is reason. The easiest way is to right-click and then delete driver. You can either do that or go into the driver editor, which is one of these somewhere in here. There should be drivers. Yeah, here, drivers. But now we should be able to move to the X-axis to affect red and move along the Y-axis to affect green. And these things, of course, mix because of this combined RGB. We can do the same thing by just putting it in a value thing that goes to green. It's an equivalent setup, although there is reason to do that because you can take this and plug it into multiple different nodes, so you only have to have one driver. So let me just paste it. Oop, Blender crashed. I would normally cut this part of the tutorial, but that is the reality. So that is some kind of bug or something. I don't know. Maybe it's because I plugged a driver into something that has the same driver. That's an issue, but it's in the tutorial. And let me just reset up quickly. Combine RGB. So I guess that's a warning to be careful with some kind of contradictions with drivers, or I don't know. But we can take the same kind of lessons and apply them to everything we talked about before with nodes. So for example, instead of just doing something simple like we just affect the amount of red, we're going to send it through some math first. So let's add a math node. And I'm going to connect this to red. So again, right now it's outputting 1 for a red, which makes it perfectly red because we have 0.5 plus, addition 0.5. So instead what I'm going to do is I'm going to do division. I'm going to set this to 1, and then for the second value, what I really wanted to stress is that you don't, again, need to pick X, Y, or Z location. You can pick scale, you can pick dimension, and in fact, anything that has a slider like this or that we can put an input for, you should be able to actually copy as a driver. So we can actually take the strength of the world. I mean, it's kind of like unrelated, but you could use that as a driver. So in this case, what I want to do is take the frame number, so this controls what frame we're on, and I'm going to right click, copy as new driver, and I'm going to paste it into the second socket. So we have 1 divided by the frame number, so the reciprocal, which means as we go frame by frame, it's going to become kind of dimmer in terms of red. So here we have 1 divided by 1, which is 1 redness, then 0.5 redness, then a third, a fourth, and as we tend towards, a bigger number, it's going to get closer to the earth. 1 divided, go frame by, we have 1, right click, copy frame number, so this controls what frame we're on. So we have 1 divided by the frame number, so the reciprocal, which means as we go frame by frame, it's going to become kind of dimmer in terms of red. So here we have 1 divided by 1, which is 1 redness, then 0.5 redness, then a third, a fourth, and as we tend towards, a bigger number, it's going to get closer to 0. And I think, let's see what happens when we play this. Yeah, you see that it's not updating on every frame, so usually it's better to just, go frame by frame, but when you render, since it renders on a frame by frame level, it should work. So sometimes viewport playback doesn't make too much sense, and I don't know if that's a bug, but this video is all about bug reporting for Blender. There are some issues, unless this is a design feature or something. Okay, so what else do we want to talk about? We can pretty much put this anywhere. I guess the last thing I want to talk about is instead of doing it the way we've been doing it, which again is kind of new to 2.81, I think. I don't think it was in 2.8. We can do it the old-fashioned way, which in some ways gives us more control if we don't want to mess with math nodes. So let's say we wanted to take the reciprocal, but not send it through the math node where we did the division. How would we do that? Well, let's say we want the scale, the X scale, to be our driver. We're going to copy this and paste it into red. So paste driver, and right now that means that if the scale is 1 and paste it onto the scale, the X scale, to be our driver. We're going to copy this and paste it into red. So paste driver, and right now that means that if the scale is 1 on the X-axis, which it is, we're going to have 1 for red, and then as we scale down on the X-axis, it gets closer to 0, which means it becomes dimmer in terms of red. If we want the reciprocal, we can either do what we did with the division, or we're just going to right click, and then we're going to edit the driver. And this is where it gets a bit confusing if you don't know what you're doing. Basically, what you're looking at right here is what is happening behind the scenes. So what we are looking at is this driver is looking at the scale of our cube, And this 0, instead of having it 1 or 2, basically means is it looking at x, y, or z, where I think 0 is x, 1 is y, and 2 is z. That's just some array stuff. Don't worry about it. But what we can do is instead of average value, we're going to set this to scripted expression. And instead of taking the scale, we're going to do 1 divided by scale. So the same way you would write it in a program or in a calculator or something. I don't know. So 1 divided by the scale, then you update. And then, right now it's still the same because 1 divided by 1 is 1. But now when we scale down, you can see it's getting brighter because it's filmic. So normally we wouldn't see that. But what I want to show you is that when we scale it up, it's going to get dimmer because now it's a reciprocal relationship. Before, it would have just stayed equally red if we were on the standard view transform. So that's the reciprocal. We can also do other kinds of math. So edit driver, we could do 1 minus the scale. So right now it's going to be perfectly black because the x scale is 1. So 1 minus 1 is 0. But then if we make it smaller because the x scale is 1. So 1 minus 1 is. So right now it's going to be perfectly black because the x scale is 1. So 1 minus 1 is 0. But then if we make it smaller, it should get more red. Yep. And you could, do any kind of expression there. And on top of that, let me delete it. If you're using a different version of Blender, if you want to call different call different data paths that for some reason you can't like right click or whatever, you can again right click whatever you want to affect. We're going to add a driver now, so instead of pasting one, we're making one from scratch. And then let's say that we want, instead of like the cube, we're going to look at the light. So that's the this light right here. So we're looking at the light, edit driver. So we have the light selected, and we can say, oh, do we want it to reference, where we're moving the light, how big it is, whatever. And I'm just going to choose like X location is fine. You could do a whole bunch of different stuff, but this is a good way to do it. In world space, meaning like what location does it have in the world instead of like local space or whatever. And that is going to be our variable. And then what's being outputted is the variable plus 0. So the way you want to think about it is we're looking at our light, we're looking at the x location, this is our variable, and we're outputting the variable plus 0, which is, the variable. Okay, so let's actually see if this works. So we have our light, I'm going to 0 it out. And you can see this actually made our cube black, and as we move our light on the x-axis, you can see it gets more red and then closer to 0. And basically that means you can kind of texture or have a material of one object reference the location of another. So you could do a lot of cool stuff with that once you do kind of more complicated math. Alternatively, what you can do, let me delete the driver. Alternatively, we can add a driver, and then instead of, picking an object, we can just, put in a arbitrary data path and do a lot of different stuff with this. So let's do single property. We can look at, I don't know. I don't really know what I want to pick. So what I'm trying to say here is you can access any part of Blender to use as your driver. So for example, you can see we can pull like stuff from fonts, we can pull stuff from lights, we can, so you can kind of have like the curvature of a spline affect the how red it is, whatever. But yeah, this is just a simple example, and now you should be able to you can see we can pull like stuff from fonts, we can pull stuff from lights, we can, so you can kind of have like the curvature of a spline affect the how red it is, whatever. But yeah, this is just a simple example, and now you should be able to use drivers, and this goes beyond just the, shader editor. You can create a driver for the strength here, so let me just add a, or you know what, let's copy this. We are going to copy as a new driver and then paste this into here. And then let me go to rendered view. What this does is as we move our cube on the x-axis, our world should be getting brighter and then darker. So it works on all parts of Blender, but I wanted to show it on the shader editor. So I know this is kind of like drivers, and this goes better. So let me just add a, or you know what, let's copy this. We are gonna copy as a new driver and then paste this into here. And then let me go to rendered view. What this does is as we move our cube on the x-axis, our world should be getting brighter and then darker. So it works on all parts of Blender, but I wanted to show it on the shader editor. So I know this is kind of a departure from all the procedural stuff, but you can see how it might be useful. So maybe you want a material that changes color depending on how close an object is to another. And if you wanted to do that, you could either do all the math about, Euclidean distance like we talked about last time, or there's actually a distance option, I think. Yeah, distance. And then you pick whatever two objects you want. But we're not going to do that here. You can probably figure out how to do that. So yeah, there you go. Another successful, oh, I'm going to burp. Another successful procedural nodes tutorial. Hopefully you enjoyed this one. If you did, the best way, the only way to support me is via Patreon. If you become a patron, it supports me, obviously, but then you also get benefits that are mostly CG Matter related, but you do get some benefits even if you just want to donate. So thank you for checking that out. Likes and subscriptions just not as valuable to me to keep making tutorials, but whatever. Thank you guys for watching and enjoying. I'm going to make more tutorials in the future, and that's it. That's the show. See ya. Hey guys, welcome back to another